My name is Mark Henderson. I'm the VP of Engineering for Equilibrium. Equilibrium.co, not .io, just to differentiate, make sure that that's understood. And this is a talk about our project Ziggurat, which is a network testing and stability framework for multiple blockchains. The problem that we're facing basically in the industry writ large is that peer-to-peer networking is extremely hard. How many developers do we have here? Engineers? Business people? Okay. Somewhere in between? Product management? Okay, cool. You might be familiar with this quote, you might be familiar with this author. Basically, there's no precedent for what we're trying to do. We have inherited things from things like Kazaa with the Kademlia framework, and there's libp2p now, and there's all these different things, but still, it's being written as we're doing it. And there's tons of moving parts and tons of different options that you can do. Are you gonna use UDP for your network? Are you gonna use TCP? Are you gonna use noise for your handshake? All these different sort of options and moving parts, and the more moving parts you have, the more things break. And on top of that, if you're building a layer 1 or layer 2 system, networking is just a little tiny piece of what you're trying to do, because you have your consensus layer and you have your smart contract layer and you have all these different things you have to deal with. You have to market your product and you have to do all these different things. So networking is like, just tiny focus. So in our quest to find a solution and also a cool word that starts with Z, we came up with this metaphor of the ziggurat, which is an ancient pyramid that uses these precise measurements on each layer to make sure that the layer beneath it can support the layer above it, and so forth. And we defined 3 layers of network stability that we aim to enhance with our product. One is conformance. Do you even have a network spec? Is there one? I think I've seen one in the wild so far in terms of all the layer 1 blockchains and things like that. And do your nodes, like does Ripple D conform to the network spec? Does Zcash D, does Zebra, etc.? The next layer is performance. You want TPS. You want your TPS numbers really high, so can you actually do it? And can you prove it beyond that? And finally, resistance. It's Web3, there's gonna be bad actors out there. How's your node gonna handle that? What are you gonna do when you encounter people who are trying to break your system for financial gain or for other nefarious purposes? Our journey thus far started with a grant from the Zcash Foundation. And I'm gonna go into how that happened, because I imagine some of you business folks are gonna be seeking grants from the XRPL Foundation at some point, or you already have one. So we have some tips, and we can talk about that. Then we got another grant from Zcash to go beyond a single node of testing to testing the network as a whole, with a network crawler and with visualizations and things like that. Q3, more chains, yay, we got the XRP ledger, we got Algorand, we're working with Polkadot, we're working with other things to try to solidify some grants or some contracts with them. And beyond that, who knows? We're looking at more topology stuff, and we have these 2 little open source projects, P2P and Spectre, that we work on that we might sort of officially release. They're on GitHub now, they're MIT licensed, but we haven't marketed them or anything like that. So, in the beginning, Zcash 2021. So what's up, guys? It's good to see you. So yeah, Thomas just walked in, so this is perfect timing. This is a story of how we got our first grant, and I think this is just instructive to take a couple minutes and just talk this through. And I phrased them as sort of commandments. You need to know thy network's governance structure. Some blockchains have an on-chain voting system for all their grants. Some blockchains are more flexible. There's a whole spectrum of that. And in our case with Zcash, it was split into the Electric Coin Company, which is sort of the for-profit arm, highly simplified, and the Zcash Foundation, which is their nonprofit arm. That should sound familiar to people in this room. At least that thing, kind of like Web3 Foundation parity, et cetera, et cetera. And know the important events in the ecosystem. We happen to know that they were trying to launch a Rust version of their Zcash node called Zebra. And we knew that that was, they wanted the two nodes to sort of be able to talk to each other. They had Zcash and they had Zebra, a new implementation of the node. We were able to get on the phone with them, and sometimes it's just as simple as asking the stakeholders what they want. And if your team can provide it, then great. So like I said, they wanted to make sure those two nodes could talk to each other, and if they were compatible, and they were not. That's sort of what we discovered. This is a disclaimer. Equilibrium has a good reputation in the industry, so we were able to get a phone call with people. You might not have that opportunity, but if you do, it really doesn't hurt to ask, how can you help? What does the ecosystem need? What does the community need? And this is what they got. And this is just a small subsample of what they got. I'll go into the larger scope later, but we found out that if you want a large number of peers to connect to, but if there's a small number of peers, it actually grinds down the performance of the node. There were a lot of useless messages getting sent, probably just cruft from old code or something like that. A lot of people were just slamming the server trying to get the Genesis blocks in Zcash, or trying to download it from the peer-to-peer network. If a node sent an unexpected message, it just automatically disconnected, which is probably a pretty safe feature, but maybe not exactly what you wanted. So we were able to sort of refine down what they were doing there. If the version timestamp didn't precisely match the sort of format, it would just crash the whole node. And outbound messages, I think this is fixed now, but at the time of making the slides, I think this is still an open issue. And again, I'm not picking on Zcash. Peer-to-peer networking is really hard. Have you seen this guy? This song, the Zcash song? Have you seen it? Check it out. It's pretty good. So now we're working with Algorand, and yay, XRP Ledger, we're doing all that stuff. Thank you, Scott. And this is the sort of smattering of what we're working on here. So again, you have the 3 layers of the Ziggurat. They're all layer 1, apparently, according to my slide. Damn PPTX format. So checking out making sure the handshake and the post handshake is, proper, and then moving into sync, and then from there, load testing, moving on to heavy load testing, and then fuzz testing, which is super cool. So all in all, we found a bunch of security flaws that we've privately submitted to the Zcash people. In that one, that's our most robust test suite. There's 188 tests across 25 suites. We've sort of come up with our own symbolic notation for how this node does this, and then there's a cool arrow, and this node is supposed to do that. It's sort of like one of those UML charts, but a little more simplified. And Prometheus compatible metrics, because why not? It's easy to do. So the how of all this is actually really cool. It's not just setting up 2 blockchain nodes and sort of tracking how they talk to each other. We actually reverse engineer the network protocol and build a synthetic node that only does networking, or primarily does networking, because it does do some other stuff in the cases of the different chains, but this thing is lightweight, it understands the network protocol better than the node probably does, and you can spin up 1,000 of them on your laptop, you can do fuzz testing, all sorts of things within this synthetic node. But aren't you reinventing the wheel? Isn't that a crazy thing to do? No, 3 reasons. We can independently develop our work outside of what the core node developers are doing. So we're not beholden to what the Ripple D devs are doing or the Zcash D devs are doing. And we even go as far as our CI pipelines are completely sub-separate from anything else. So we're really agile in how we go about doing that. So yeah, the fact that we cannot easily introspect into those behavior, even though we totally can because we have a node running there and we can instrument it. It's a feature. It's what you want when you're black box testing something. You don't want to know what's going on. You just want to know about its behavior. And in the absence of a formal networking spec, the Ziggurat test suite sort of becomes the spec of future node implementations. If somebody comes along and wants to do a light client, things like that, that's how that works. So, it's a pretty quick talk. Actually, maybe we can just have some discussion, but this is my prediction. It's just a matter of time before this happens. It hasn't happened yet. Everything's been on the consensus layer or a broken smart contract or something like that, but mark my words. And the whole goal of this project is to make me wrong about this. I want to prove myself wrong by protecting as many chains as I can. And that's that. For more information about this prediction, there's a DARPA report by a company called Trail of Bits. Have you seen this? Yeah, it's horrifying. And it goes into all the different network vulnerabilities. It goes into these degrees of centrality in a network and where the pain points and the sort of failure points are. So check that out, and thank you. I'll be available now for questions and out there. So that's all. Good.